Namaste, and thank you for choosing to watch this video. Let's begin. As kids, we all have played with balloons, filled air in them. A balloon is a flexible membrane that can be filled with gas and made from material such as rubber or latex. Now, balloons have a certain elasticity to them. The act of stretching a balloon fills it with potential energy. When it is released, the potential energy is converted to kinetic energy and the balloon snaps back into its original position, and it will be just a thin membrane. So, we tie the balloon at its end so that it retains its shape, whatever the shape may be. The string or the stick, when attached to the balloon, helps us to hold it. Hot air balloons work on the very simple principle that hot air rises as it is less dense than cold air. This balloon has a set of burners to heat the air, which fills the envelope and causes the lift. Sandbags in the basket keep the balloon anchored on the ground. All of us have also enjoyed the thrill of jumping on this bouncy house. How does this work? Inflatable bouncers function by continuous airflow. A powered air blower continuously pumps air into the inflatable while it's in use. Even in an air mattress, air is pumped through valve and it retains the shape of the mattress. A pneumatic structure is a system of components that is supported by air in the same manner that a balloon is supported by air. The components of a pneumatic structure consist of a membrane, supporting cables, anchorage system, and an HVAC system. It is a membrane which carries load developed by tensile forces. Let us now see the types of pneumatic structures. First is air-supported structures. They have air higher than the atmospheric pressure supporting the envelope. Airlocks or revolving doors help to maintain the internal pressure. Air must be constantly provided. They have a lifespan of 20 to 25 years, relatively low cost. They are either anchored to the ground or to the wall so that leakage is prevented. The second type is air-inflated structures. As the name suggests, it has two membranes. The supporting frames consist of air under high pressure. Internal pressure of building remains at atmospheric pressure. There is no restriction in number and size of openings. It has the ability to support itself. They have potential to support an attached surface too. Classification of pneumatic structure can also depend on the surface curvature as synclastic or anticlastic, that is, curved in the same direction or curved in opposite direction. Wind and snow loads are the primary loads acting on these structures, for which the anchorage has to be designed. It is done as ballast anchorage system or ground anchorage system. The membrane or the envelope material has to be high in tensile strength, non-reactive, waterproof, self-cleaning, UV resistant and long-lasting. The most common materials are polyester, nylon, PTFE, ETFE with coatings to impart set properties. Pneumatic structures are lightweight, can cover large spans to have column-free spaces. Quick erection and dismantling is possible and are not that expensive as temporary structures. Good natural lighting is easily achievable. Pneumatic structures have varied applications. They can be used to cover swimming pools, stadiums, for botanical gardens, and as temporary structures for relief and military purposes. The possibilities are endless. That's all for now, and I hope you enjoyed learning today. This is Architect Medha signing off.